Hello everyone. So we are looking at questions from our phase 5 matrix chapter exercise 2. So these are questions from exercise 2, question number 6. Okay, question number 6 is there is a matrix A given which is an orthogonal matrix with elements in terms of alpha and beta, and the other condition is that the roots of given two quadratic is that the roots other than the common roots alpha and beta are the roots other than the common roots of the given quadratic. Fine. So first of all, with whatever is given to us, we have to start from there. So this is an orthogonal matrix. Let us apply the condition of orthogonality. So A into A transverse is equal to I. This is simply the property. So from here, let's see what we get. Alpha, beta minus beta, alpha. So with its transpose, if we multiply, alpha, beta minus beta, alpha. Okay, so when we multiply alpha square plus beta square, so we get alpha square plus beta square, and then alpha, beta, get 0 here. Then here alpha, beta, alpha 0, and then minus beta, so beta square, alpha square. So we get alpha square plus beta square. So we get this. And if we compare this with I, so if we compare this with I 0, 0, 1, so from here we can safely assume or write that alpha squared plus beta squared is equal to 1. Alpha squared plus beta squared is equal to 1. So this is our starting point. Now our other conditions that are given are x squared minus px plus q is equal to 0. This is one quadratic. And x squared plus px minus q is equal to 0. And if you understand what is given to us is, let us take some other time. So it is given that here, let's say if the root is alpha and the other root, let's say, is gamma. And here, if it is beta, then other root is gamma. I don't know if this is, you can see this. So now the common roots are gamma here. So if we just apply that condition here, so gamma squared minus p gamma plus q is equal to 0. And from here, we say gamma squared minus p gamma, so it's plus here, minus q is equal to 0. From this, if we just subtract the two, or just add, so we get 2 gamma square is equal to 0. From here, we can safely assume that gamma is equal to 0. So the common roots here are 0. And if we sum the two roots, so if q is equal to 0, so now let us find out alpha square plus gamma square and beta square plus gamma square from the two. So how do we find sum of the roots of a quadratic? Sum of the root, that is p square minus 4 into the product of the root, which is q here. Now here again, p square and product of the root, that is 4. We have just now seen that gamma is equal to 0. So that means alpha square plus beta square is equal to 2p square. This and this will get cancelled. So also alpha square plus beta square is equal to 1. So this is equal to 1. So from here we can say p is equal to 1 by 2 root plus minus. And product of the root, that is q, gives you the product of the root. If one of the root is 0, that means q is also 0. Option should be q is equal to 0 and c is equal to plus minus root 2. I think this is what also the, yes, here what they have done is they have added the 2. From there, they have inferred that one of the common root is 0, and then the same thing. From the sum of the root and product of the root also, you can take, if the product of the root here is sum of the root is p, so alpha plus gamma, so from here also you can infer. So that way also you can do, or from the sum of the roots you can. Okay. Thank you.